What is soil? Read aloud for pages 3 through 8 in your FOSS Science textbook. What is soil? Have you ever dug a hole in the ground? What did you remove to make the hole? Soil. Sometimes people call it dirt, but a scientist calls the layer of diggable material that covers planet Earth soil. What is soil? If you pick up a handful of soil and look at it closely, you might be able to see and feel what soil is made of. Soil is mostly made of several sizes of rock. You might see pebbles and smaller pieces of gravel. Soil usually contains sand. Particles of sand are really tiny rocks. Some pieces of rock are even smaller than grains of sand. Smaller pieces are called silt. The smallest piece of rock are clay particles. Clay particles are too small to see, but you can feel them. Clay feels slippery when it is wet. So soil is a mixture of different size rocks, pebbles, gravel, particles of sand, and even smaller particles of silt and clay, along with water and air. Rocks, air, and water are earth materials, but there is more to soil than earth materials. So if we look at the picture underneath, the caption says soil is mostly made of rock in several sizes along with water and air. And if we look at the chart on the bottom of page 3, we have the sizes of rock in order from the particle that is the largest to the smallest, going from pebble to gravel to sand to silt to clay, being invisible to the bare eye. Page 4. Soil also contains organic material. Organic material is the remains of dead plants and animals. Plants send their roots into the soil and animals dig into the soil. When plants and animals die, their remains become part of the soil. Plants and animals decay into tiny pieces called humus. Humus provides nutrients for plants. Humus also helps the soil retain water. What is an animal that lives in soil? Worms. Worms are good for soil and help plants grow. Worms burrow through the soil. As they move, worms mix the soil and make passageways for oil and water, for air and water. Worm waste also adds nutrients that are good for soil and plants. And the caption reads, "A worm in soil enriched with humus." Not all soils are alike. Some kinds of soil have more humus. Some soils have more clay. Some have more sand, pebbles, and gravel. So down at the bottom it says, what differences do you see in the soils above? The one on the right is very rocky as compared to the one on the left. The one on the left may have more grass, more dirt, more soil, more humus. The one on the right, in the pictures in the textbook, has a little bit more water in it because it's near a stream. The one on the left is probably from a forest. Where do you think these soils are found? So the one on the left is probably found near a forest, and the one on the right is probably found in a marshy area or in the area of a stream or a river. So now we're on the topic of weathering, page 6. Weathering is broken down into two categories, physical weathering and chemical weathering. So on page 6, we're going to start off with physical weathering. So pebbles and sand are pieces of rock. Pebbles are pretty big. You can count a handful of pebbles. Pieces of sand are tiny. You can't count the particles in a handful of sand. All pebbles and sand particles start out as huge masses of rock the size of mountains. How do mountains break down into pebbles and sand? The answer is weathering. Weathering is the breaking apart of rocks into smaller pieces. Weathering happens to all rocks when they are exposed to water and air. Physical weathering. Rocks break down in two ways. Physical weathering makes rocks smaller but does not change the rocks in any other way. When a big rock falls from the side of a cliff, it breaks into lots of smaller rocks. All the minerals in the small rocks are the same as the minerals in the big rock. When rocks get hot and then cold, they can crack. Sometimes water gets into cracks in rocks. Water expands when it freezes. It can expand enough to break big sections of rock along with the crack. When ice melts, the rock may break into smaller pieces. So on the bottom left, physical weathering of cliffs, and then on the right, a rock weathered by freezing and thawing of water. And on page 7, let's read about chemical weathering. Chemical weathering happens when minerals in rocks are changed by chemicals in water and air. The starting minerals change into new substances. Many rocks contain iron. When oxygen in air comes in contact with iron, the iron in the rock can rust. Rust is iron oxide. Iron oxide is softer than other iron minerals. This causes the rock to break apart faster. Carbon dioxide gas in the air dissolves in water droplets. This makes acid. The acid droplets can fall as rain. The acid causes the calcite in limestone and marble to make holes. This is a chemical change. Monuments, buildings, and gravestones made of marble or limestone change and weaken when exposed to acid rain. Salt can cause chemical weathering. Salt water can react with minerals in rocks to make new minerals. When the new substances are softer than the original mineral, holes can form. The weak rock breaks up and falls apart more easily. So up at the top, you see a picture chemical weathering of a rock containing iron. Then you see a picture chemical weathering of marble by acid rain. And then on the bottom, you see chemical weathering of sandstone by salt water. And if you think about it, whenever it snows and the town puts down salt on the pavement for the cars so that there are no accidents, you'll notice that the roads start to crumble and we get potholes, and that's because of a chemical weathering. The salt causes the breakdown of the roads, and then they start making holes, and then we start getting potholes. On the last slide, there's the Quizlet link to study and review your vocabulary from What is Soil? Good luck, fourth graders.